Hi, good morning, good afternoon, and good evening, everyone. My name is Praveen, and I have 12 plus years of experience in networking. So I'm doing training for almost 6, 7 years now. So my primary expertise is I'm doing data center migrations. I'm mostly working on data centers and wireless and security. Security is my secondary skills. Mostly I'm into routing and switching and wireless. And I'm also taking care of load balancers. So I do have experience with multiple products. And when I'm talking about this course, yeah, this is Wireshark Basic to Advanced training, and I'll be the instructor for this course. So I will explain how it works, the training, how it works. So it will be a half an hour session. So totally it is 2 hour session. So we'll have two Q&A sessions for every hour. So we'll cover two topics. And in the first half, you guys have a Q&A session where you can ask your questions, your doubts related to the topic what we are discussing. And you will have your second Q&A session around 11:45. So it's just quick 15 minutes Q&A session. Uh, it happens in two intervals. So that's how it's going to work. And the whole training is we will stick to 80% practical and 20% theory. So we'll be covering the whole thing. Wherever it's really essential for PPT, we'll go for it. Or mostly we will do everything with Wireshark there. This is how the training works here. So do you guys have any questions on this? I think you guys have
No.
unmute permissions, right?
Sir, the recordings will automatically update into that app, right? We don't need to record or,
Yeah, correct. You will get your recorded videos. You will have portal access where you can watch all the courses
Okay.
in
Okay.
one single portal. Mushkan will help you with that. So you will
Okay.
get your login credentials, then you can watch anytime, anywhere, on one single device at a time.
Okay.
Yeah.
Just-
Praveen, so the recording will cover the question and answer session as well, right?
Sorry, what is that, Suchit?
Uh, like the recordings will cover question and answer session as
Yeah.
okay,
Correct.
great.
Yeah. We'll break, yeah, that. I mean, once we are done with that, so we'll have I'll stop the recording and I'll record the Q&A session. So we will have two Q&A sessions
In each session.
in each session. Yeah.
Okay.
Correct. So it's
So,
how it's going to
So,
work is we will do a topic and we'll do a Q&A in one go, and then we'll stop the recording and then we'll record again and we'll do the second session. Or maybe sometimes it continues and you will have your Q&A in the middle.
I mean, this course is hi, my name is Saurabh. So this course is mainly focused on deep packet analysis instead of how we're going to install Wireshark, not in that stuff. Because I'm more into learning about why we see spurious retransmissions, dupacks, the reason for that. Like it's more focused on the deep packet analysis. This course.
Yeah, absolutely. Yeah, correct. Like
Okay.
how spurious retransmission happens, what is fast retransmission, what is the difference, why it happens. Yeah. What is dupacks? Why do you see dupacks? Yes. We cover the whole TCP.
Okay.
Yeah.
Hi, Praveen. This is Raju. Just wanted to understand that, I'm sorry, I just joined. And you're going to cover the complete troubleshooting, right? Like identifying the latency issues, detecting the packet drops and retransmissions, diagnosing the application level and network level problems.
Yeah. Yes, Raju. Yes.
Perfect. Yeah. Fine.
Yeah. We are discussing that. Yeah. Yeah. If you
Okay.
look at this course material, can you see my screen?
Yes.
If you see this under the TCP topics, you have this selective acknowledgement, you have retransmissions, then window scaling factor, explicit congestion notification, everything related to latencies. And there are a few more, right? When we talk about retransmissions, fast retransmissions, various retransmissions, all kind of retransmissions, not only limited to this. So we will try to cover most out of TCP along with troubleshooting. So we have, for every session, we have a lab.
Okay.
So someone he asked me about flow graphs, TCP UDP stream and flow graphs. So we have labs for every topic what we are discussing.
All right, fair point. Thank you.
Yeah, thank you. Yeah. So this is how it works. So I'll make, if you guys when we are teaching, the biggest problem is sometimes the people, they interrupt the sessions. I mean, I'm not telling they're interrupting the session, that's actually breaks the session flow. So we always mute the students. Will mute you in the beginning, and during the Q&A session you can note down your questions and you can ask your questions. That's how it's going to work. So any questions on this so far, what we discussed about the pattern of learning and how we are going to do the training? Okay, cool. So I'm going to mute everyone now, and let's discuss the first topic today. And I will do a quick walk through with the contents, what we are going to discuss. So you have your chat window. In the meantime, if you have any questions, if some people they feel struggle, okay, I should ask a question right away now, you can always post your questions in the chat. So once you get your Q&A session, we'll go one by one, and the questions whatever we have, we'll go in an order. So we will clarify all your questions. So always make use of the chat. Don't think that I can't ask your questions right away. Ask your questions in the chat, keep it in the chat, and ask one by one. We will discuss. Yeah. So the course starts with the basic of networking. What is OSI model? What is TCP IP? This is all not something we are going to do a theory. We are going to see this practically in the Wireshark. And we will see the functions and the protocols of every layer and how this encapsulation happens in every layer. And we'll see the differences of duplexes, different duplexes, half duplex, full duplex, duplex mismatch, speeds. Then also we'll see the how auto negotiation works, what is MDIX. Then we will see the difference between hub, switch, router. This is all very quick sessions. We will go through this, but mostly we will cover this in practically in the Wireshark using that. Then this all happens when the two devices communicate with each other, even in the same broadcast domain or different broadcast domains. So we should know how ARP works and exactly how the ARP protocol works, and inside the Wireshark, how you're going to figure out the every packet flow of ARP. So we'll see the detailed parameters of ARP headers, if it happens in the different subnet and same subnet, how it happens, and what is proxy ARP, what is gratuitous ARP. So in the ARP topic, the most widely used is gratuitous ARP. When you troubleshoot a problem, if you have seen, there will be a problem with the duplicate IP address. So gratuitous ARP is something is going to say if there are two devices with same IP address on a network, example 10.0.0.2, if both devices are using 10.0.0.2 and both is going to broadcast, hey, I am 10.0.0.2 with the MAC address. So you'll get the notification, right, in your switches, duplicate address found. Then you'll track and you'll find. But in Wireshark, how it helps is inside your broadcast domain, if there is multiple gratuitous ARP happens for more than one or two devices, you can take a look very quickly. Instead of checking for the logs, you can see the MAC addresses, and based on the MAC addresses, you can track down those MAC addresses in the switch and you can figure out. Then we will see what is CRC errors, checksum, and Ethernet header structures. What is we mostly look into what is destination MAC, source MAC, and how in the routing destination MACs and source MACs are changing, and how in the Wireshark will help me to figure out. So you may think what is a great thing I can learn in layer 2. It's not like that. If there is any duplicate IP address coming from, so you can exactly figure out, okay, the Cretaceous apps came in, but what is the MAC address? So the MAC address plays a very important role in your switching. So we will learn about that, how this Ethernet header plays when it comes to troubleshooting and when you find a problem. Then we will see what is IP addressing. It's all basics we know, but we'll brush up this, and then we'll go for the different MTUs. So when it comes to actual troubleshooting, IP is just, we feel limited to just IP to IP communication. So here we will see what is fragmentation, because most of the time, because of fragmentation, there will be a slowness, and we will exactly see who is fragmenting the packets and where exactly I have to do the where I have to do a capture for the fragmentation. And also we can see in the packet capture how these packets are fragmented and reassembled. And we will do a scenario with multiple MTU, maximum transmission unit. We know that. So we see this, what is MTU and how MTU actually affects your connections, and we will do a troubleshooting with that. And also we'll see how this layer 2, layer 3 addresses keep changing, right? Because your layer 3 address remains the same, whereas your layer 2 addresses keep changing per every hop. So your source and destination IP are never going to change until there is a NAT in the middle. So we'll see how this layer 2 and layer 3 packets, it flows through, and how this changes when it flows through switch routers and firewalls. What is PMTU, Path Discover MTU? We'll discuss that. We have a lab for Path MTU, and we will see what is TTL and what is IP options. Loose source route, strict source route is something topic in the security. That's something we'll cover in the lab for it. Then we will discuss about the ICMP messages, different types of ICMP messages, where it helps. If I try to ping, I see request timed out, and also sometimes you don't see anything. It is just with the dots or asterisks when you do a trace route. So in those situations, how you are going to figure out, is it the particular ICMP ICMP protocol is blocked, or is there is no routing? So we will make use of different ICMP messages to figure out those. So we'll see the difference between ping, traceroute, and traceRT. Traceroute, I think in some devices, network devices, traceroute works, and traceT works on your Windows. So we'll see the difference between what is UDP-based traceroute and what is ICMP-based traceroute. Then the very big topic is, and for every topics, if you see, there is a discovery lab. So here we will do the ping and traceroute error with packet analysis. We will see that. Then coming to the TCP UDP, it's a pretty big topic we have. So we will go inside the TCP, not limited to just SYN, SYN-ACK, ACK. So we will know what is, along with the three-way handshake, what is explicit congestion notification, if there is any congestion in the network. And we will see what is window scaling factor, what is window size, what is sliding window, what is zero window. If your window is full, if the receiver is not able to receive any more packets, and if you want to wait to send your packets, then you will get the TCP zero window. So for that, we will be using the iPerf tool to practice all these kind of scenarios. TCP windows, zero windows, sliding windows, all these topics will be covered with iPerf tool. If you guys are aware of it, I think most of us, you might be using it. So we will do the troubleshooting scenario in session with iPerf. Then we'll see what is IPMTU. There are two types of MTU. One is IPMTU, and one more is normal MTU. As this, what is maximum segment size? Why we have to change the maximum segment size when it comes to GRE or some other protocol? If it fills up the MSS, why we are to reduce the MSS? So those scenarios we will discuss. what MSS, I know what is the role of MSS there, and why we have to reduce the MSS when it comes to GRE and some other protocol if there is some additional header is added. So we'll see all kind of flags, TCP flags in ACK, FIN, reset, push, and urge. Push are still mostly used, but urge pointer is not. Urge flag is not most widely used. I mean, it's deprecated by. Most of the application doesn't support the urgent pointer. So mostly we will cover SYN, ACK, FIN, reset, and push. So we'll see what is slow control, what is retransmission, fast retransmission, and what is previous retransmission. What is selective acknowledgement, what is SAC options, and we'll see what is TCP timers, idle time, and what is persistence, keep alive, and all this related to the TCP timers. We have everything in one lab once we discuss. And yeah, this is all pretty unaware topic, but we will discuss about the MSS, CWND, RWND, threshold, and RTT. And we'll see UDP specific protocols, DHCP, DNS. So we'll do that in the lab, difference between TCP and UDP, and what is the logical common ports, what is well-known ports, what is the random ports, what is the difference, and how do you find that? And then we will discuss about the whole DNS process, how you will troubleshoot your DNS related problem. Right? Because DNS plays a vital role. If your DNS query is not happening, your whole communication never going to happen. Right? Even though if you have your routing, if your DNS is not able to resolve, then your communication is not going to happen. So if there is any problem with the DNS, how you're going to figure out? DNS is very quick and small thing, but troubleshooting, you need better understanding. It is just query and query response, only two packets. And a user sends a DNS query and we should get a query response back. But what happens in the background, that's something we will see. What is iterative query, what is recursive query, and if there is any problem, how do you flush your cache if there is some updates happens in your DNS server. So we will do that everything in a DNS lab. And DHCP, most of the size related problem and everything, when we troubleshoot with the DHCP, we will see list of use cases. What if a DHCP server has been configured with the wrong default gateway? It's going to, for the discover messages, obviously the server will respond back. It will offer the packet. But what if I get a wrong IP address? Still you get a DHCP IP back, but people don't look into the default gateway, and obviously your packet will not be routed. So it's a problem with the layer 3, but how with the help of DHCP packet capture you're going to figure out it's a problem with layer 3. And you'll see all these DHCP options used for wireless. There is few DHCP option 43, I think so. I don't remember that properly. So DHCP option 43 and all other list of DHCP options that's been widely used for other communication, voice and wireless. And in the switching lab, we will see what is spanning tree, what is LACP, what is ARP table and CAM table, what is broadcast domain, collision domain, and what is cut through, fragment free, store and forward, and all this. And we will do a switching lab for it. So routing plays a big role. So in routing, we'll see what are the difference between this distance vector and path vector protocols, and the RIP is not much we are going to cover because it is deprecated. So static, default, dynamic, OSPF and BGP. So one thing I have to change, this RIP is no more. So OSPF is a pretty big topic. There you will see all your right from your let's say type 1 to type 7. You will see that what the different area types in OSPF and where exactly DR and BDR election happens. And if there is an OSPF message adjacency happens, then we are going to stitch the topics what we discussed previously. So here comes when you have some problem with your MTU, your OSPF neighborship is not going to happen. So how you are going to check your MTU in a Wireshark capture when you do troubleshooting with OSPF? And if you send some kind of LSA messages, and if this LSA message is not propagated and reaching the destination, so how I'm going to figure out that? Do I receive those particular LSA messages from the specific router or not? So that's something we are going deep packet level inside the Wireshark to figure out those problems. And BGP, the BGP fundamentals we will learn here, the BGP messages, what is eBGP, what is iBGP, and attributes. So don't just think this is just a fundamentals. Here in BGP, we are looking into how eBGP and iBGP relationship happens and what are the most widely used attributes. So we're going to discuss a lot more deep about the BGP. So the first topic is the BGP fundamentals and all the state messages and message types and your neighbor establishment process, how it happens. So I'll tell you one interesting thing about BGP. So I have seen people when they troubleshoot with BGP. Do you guys ever think why do I need an underlay routing protocol for BGP? If you know the answers, you can put it in the chat. Actually, what happens there? BGP works in a little different compared to other protocols. If you do an OSPF, or what generally we do, we advertise the routes in every device, right? Areas are different. The fundamentals of OSPF, I'm telling you, you're going to say, I got 4 networks, I got 4 IP interfaces configured, so I have 4 layer 3 interfaces, I'm going to advertise this. So obviously the neighbor device is going to receive it and it will send it back its own all the layer 3 informations back to the receiver or sender. So example, you're talking about 2 scenarios. But in BGP, do you think if you advertise the network alone, does it going to, do you really exchange your routes in BGP? So BGP, fundamentally it works on TCP port number 179. So to establish a TCP connection, you need a routing. So always BGP is dependent on underlay routing. So BGP is a overlay routing. So this is something most people, they don't understand this. So that's why we do an underlay routing. So you need OSPF or any underlay routing before you establish your BGP connection. So the very fundamental and the basic is for 2 destination, you should have your route in your route table to establish your BGP neighborship. So in you're bringing the device into your BGP, but you should have a routing for it. Because if there is no routing, your TCP connection establishment will never happen. Because for the 3-way handshake to happen, you should have end-to-end reachability. So that's why we use an underlay routing. Then we will do a BGP for the neighborship. So this is so important to understand in BGP. Even they ask, I don't know, in the interviews, even I have seen people, they don't ask this question, but this is a very basic foundation of BGP, how it works. Then comes to firewall, we will see where to position a firewall, what is stateful, stateless firewall, what is session table, what is state table, what is a transparent mode firewall, what is layer 3 mode firewall, what is zone-based firewall. So we'll use a Palo Alto for this. Then we will see different types of NAT, source NAT, destination NAT, NAT versus PAT, and how NAT works, what is unidirectional NAT, and what is bidirectional NAT, and what is PAT, how this port number changes, and the packet flows through a PAT device. Then we have a PAT lab for it. And we will also discuss the packet flow through a firewall, how the TCP and UDPs are handled through the firewall. And we will do an FTP session in a firewall to see, and we will configure the ACL in the firewall. But doing all this along with the packet capture, if you see, okay, if there is something blocking ACL, what Wireshark is going to tell me, right? Because the biggest problem we hear is, we know there is something blocking, but we don't know who is blocking it. Even with the log, sometimes we couldn't figure out if there is any device in the middle is doing that. So with the help of Wireshark and the troubleshooting tools what we have in the firewall, we are combining all together and we can, leverage our troubleshooting. So this basically to elevate your troubleshooting to understand better and isolate a problem very quickly. Then we'll see what is the types of VPNs we have, what is confidentiality, authentication, not just theory. So we'll go see what is key encryption hash, what are the algorithms used when the IKE phase 1 negotiation happens, who is proposing what kind of algorithm is being proposed, and what are the protocols and what are the algorithms is used, right? So all this packet level information you will see in the Wireshark using that. So we'll see that the difference between the route-based VPN, policy-based VPN. We'll use virtual tunnel interfaces for route-based VPNs, and we exchange routes. And in the policy-based VPN, we'll be using an ACL to do that, and we will do the troubleshooting. And if you see, the IPsec is a pretty big topic. So if you see, we are going to see what is asymmetric encryption, what is symmetric encryption, then all the 6 main messages that happens when you establish your IPsec connection. And we will also do the aggressive mode. So because instead of 6 messages, it becomes 3 messages. Then the quick mode, what is perfect forward secrecy, where it will be used, right? And what is the IPsec modes, tunnel mode and transparent mode. And we will do an IPsec with AH and ESP. AH, if you know, is only hashing. AH doesn't do an encryption. So I think FortiGate and some devices, they don't use AH-based IPsec. I believe they use only ESP-based IPsecs. So we'll do this lab. And along with that, we will see when your IPsec negotiation happens, there will be something called a NAT discovery happens. So we'll see that exact packet of 4500. This should be opened. If there is any NATing happening in the middle, if you build an IPsec tunnel between point A to point B, 2 devices, if there is something in the middle and if it is doing a NAT, so how do you see this packet there? So it's a NAT is something blocking your IPsec. So we have a lab for it, and we'll do that lab. And we'll do the IPsec overlapping subnets. We'll be using the same subnet using a VRF. We route the packets, and we will establish an IPsec connection on top of it. Then we'll be troubleshooting a lot about IPsec, all the 6 messages, phase 1 troubleshooting, phase 2 troubleshooting, overlapping subnet scenarios, and NAT-T, NAT traversal problems, a lot with VPNs. So the final piece is SSL. So SSL plays a key role, we know. So we will see all the SSL messages, right from your proposal, then your record layer related troubleshooting problem, if there is a problem with the root CA or it's a problem with the corrupted certificate. Then we will see if there is any problem with the algorithm mismatches, why your connection is not being established, and if there is any problem with the certificate revocation, and how do you find the self-signed certificate. And also along with this, we have a tool, OpenSSL, we will be using. So we will be creating the certificate, self-signed certificate. We will create a root certificate. So we will know where RSA key is used, what is public key and what is private key, how it is used. And we will see inside the Windows Trusted Store what is the need of root certificate, and why we say it is a root certificate, why it is called a self-signed certificate, and if there is any problem with the root certificate related problem in Wireshark, how I am going to find out. So in the mostly we focus when it comes to troubleshooting, we will be focusing more on record layers. So we'll see the difference between alert. Sometimes it can be ignored. It is just an alert, or it's a problem with the handshake, or if there is any problem with the application related problem, you will find everything using the record layer. So we'll see what is the level warning and fatal errors. This can be ignored because if there is some encryption decryption happens, sometimes Wireshark couldn't decrypt this packets, or maybe it cannot read the data, and it's going to give you an alert saying that it's an alert, level warning, fatal alerts. So we'll see the differences. As I said, the common certificate errors, we'll know unknown certificate, untrusted issuer, expired certificate, right? Because how do you know that the certificate is expired? If you open up the SSL layer and if you look through the options and you will see the validity of the certificate there, then you will get to know, okay, this handshake is not happening because the certificate is expired, so the connection is not happening. So we'll see traffic selectors, proxy IDs, and there are multiple traffic selector entries there. So this is all deep level about the SSL here. And also we will discuss about the TLS 1.2 and TLS 1.3 along with this, the differences. There is little difference in TLS 1.2 and TLS 1.3. So this is about the whole course content. And today's topic is what is the basic of networking, right? And before that, I will explain about the tool, because I know people, they have a good experience with that, but what I heard from so many of you is that you don't know the sequence of Wireshark, where to start with, how to see, what are the options. So we are going to see the basic of Wireshark now. I mean, what is the tool, and what are all the options that I can play with and to use for my troubleshooting. Yeah. So let me fire up the Wireshark here. So whenever you open up a Wireshark for a PC, this is how you will see the traffic. Even you're troubleshooting a problem with a user, right? We'll come back to that later about how we use this with the routers, switches, and firewalls. So in the very basic is like this. So when you open up, if you imagine you're troubleshooting a problem on a client computer and you have a multiple traffic selectors here. So my traffic is mostly going through my Wi-Fi. If you see the little graph running on top of it, I'm going to double click this. It's going to dump all my packets here. So let me stop this. So what you should look when you do a capture, and how to do this filters and all this parameters, and how I can customize my windows, how I can customize the tool. So the very first thing I would say is, in the Wireshark, if you open up your Wireshark, the very first thing you should see is a packets here. So now I stopped this, there is no packet running. So how do I do a capture again? So I have to click on this Wireshark icon here, continue without saying, it will again start my capture. It's a fresh capture. And you can see the packets is keep running. Sorry. So it is dumping all the traffic. And stop right over here. And the very useful information what you will get, it is expert info here. You see this is the highest expert information level data. So all these logs are, we say it's an expert logs. So when you're troubleshooting a problem in a client computer, this is the first thing I want you guys to check. So when I click this, the very first thing what bothers me here, they have differentiated with colors. Yeah. If you see this is a blue color, this is a duplicate acknowledgement. This bothers me. And if you see this Windows update and fin packet, okay, that's fine. So this is all TCP, SYN, and ACK packet. And this is all reset packets. Correct. So today we are talking about Wireshark, the basic of Wireshark, and the basic of networking, right? So when you open the Wireshark, if I click on any packet, if I go to any packet here, say for example, I want to test a packet, if I just want to learn this for the very first time, click on any packet. So what it says, it is telling this is my source, this is my destination, this is my protocol. And if you see this arrow mark right over here, what you should understand is, let me take my pen. So what you should focus on is, first, very primary is source. This is destination. This is source port. This is the destination port. So this is the flow. First source port, destination IP, destination port. So these are the four key connections that happens in TCP. So, okay, so now we are very basics of Wireshark. So here, data, this all, we can't decode anything. So where your actual layer starts from. So your layer starts from layer 2. It comes from top to down approach. So first you will see is your layer 2, layer 3, then layer 4. So only there are two transports in layer 4. One is TCP and one is UDP. There are few more coming in. I mean, they are using quick protocol, if you guys are heard about that. But mostly still, most of the applications are still using TCP, UDP. And for your information, you want to know about this, as I said, you will have the quick. also one other protocol along with your transport protocol. So when we talk about layer 4, you have a protocol quick, TCP, then UDP. So how your hierarchy works, as I said, that comes from your top to bottom approach. So here comes your layer 2, then comes your layer 3, this is your layer 4. So if you go to the upper layer, so how do I filter that quickly? So this is an option where you can filter your packets. This is called a display filter. Right here, this is called a display filter. If you want to filter anything, you have to type your commands here. So it will filter the packet. So this is the whole TCP dump. And if I click on anything, this is how you will start your layers with. Layer 2, layer 3, layer 4. So if I'm clicking on this, I know this is more than a layer 4. And where exactly this TLS fits in? Most people, they think, is it a layer 7 protocol? You can answer this question in the chat. So how your packet structure looks, this is your layer 2. Then comes your layer 3. Then comes your layer 4. So here fits your TLS. Then your application layer. So this sits between your layer 7 and layer 4 here. So what is the purpose of this? This is just to encrypt your traffic. So whatever you have inside your layer 7, say for example, your HTTP, this is all wrapped inside the TLS. This is encrypted. So when you do a decryption, when you decrypt this TLS packet, you can see what is inside your layer 7. So if I do this, clear this, so I can see, if I expand this, I can see the destination MAC, source MAC. Always in the layer 2, you should understand, always comes your destination MAC, where the packet goes. Then it actually shows, displays your source packet. And if you come to your layer 3, we are not discussing much about this now. We're just seeing how Wireshark works. So you can see this your TCP packet. Do you see anything on top of this? All your application protocol is, you can see TLS, it is using HTTP, but do you see anything inside your application data? Everything is encrypted. And also, even though it is encrypted, what you can still see your TLS version, what is being used. Right? You can also see that here. What is the TLS version used here? See, if you see this protocol here, you can see the TLS version right over here. So this is a sequence, this is how you should see. You should know what are the options where I can see this is the data, and you can see till layer 4. Once you decrypt your traffic, you can actually see your layer 7 information. So coming back to the basics of networking. So we saw what is the layer 2, what is the layer 3, and we will see how this encapsulation overhead happens, right? So if I just take a conversation, people said, okay, I couldn't find a problem. I don't know how to follow a packet. Okay, let's take this reset packet. So if people are telling, okay, I have some problem, I do see a lot of resets. The very first thing you have to do is you have to always click your expert info first. That is your step 1. So you have to check, okay, how many reset packets I got? Okay, I have it here. So in the beginning, you may not know your filters. So if you just hover over a mouse on top of that, you will get the option, right? tcp.connection.reset. So if I drag it, sorry, if I click on this, right click, apply as a filter, and if I give selected, so it's going to select the filter tcp.connection.reset. Close this. In the whole conversation so far, what I captured, I can see only one reset. So if I click on that, can I see from layer 2 to layer 4? So if I expand this, okay, from this I know, okay, this is going to the destination. This is my router. This is my source. This is my computer, this computer where we are running the Wireshark. And if you see, this is my source source IP, and this is my destination IP. See, in ECN packets and explicit congestion notification, there's no congestion, nothing you can see here right now. So what is the maximum I can see? Layer 2, layer 3, and layer 4. Only if you decrypt, you can see what is happening inside your layer 4. So how you want to customize your Wireshark when you have it? Okay, I know how to see the packets. So you want to see the drops. So do you see any drops here? Drop packet, nothing for now. That's fine. We'll see the scenario where we can see the drop packet. So now going to the layer deeper. The first thing we are going to discuss about functions and protocol of each layer, right? So we know, as I said, we are going to discuss about layer 2, layer 3, layer 4, and what is inside the layer 7. We are not going to discuss about the session layer, what is happening inside, because we have no control with that. So as a network engineer, so what can I do here to troubleshoot a problem? So mostly what happens, we generally encounter a problem with slowness. We encounter a problem with if there is any blocks with the ports. And we will do a deep troubleshooting if there is any problem with the latency, with application level, right? So how this is packed up and how it is routed back. Now, I mean, people are from a different background and they know routing and switching. They're from security domain. But a quick run through with how the packets are encapsulated. So for that, let me open the PowerPoint. Let's go to the whiteboard here. So in Wireshark, what we are seeing in the Wireshark, as I said, it's a top-down approach. So you see from your layer 2, then you see your layer 3 information, you see your layer 4 information, and TLS fits right over here, and here comes your layer 7. So if it is encrypted, you can't see any packet here, right? So in layer 2, what you will see your destination MAC, then comes your source MAC. Other than that, we don't see anything inside. In layer 4, you see your source IP, your destination IP. But we never go beyond this, right? So there is something called a TTL, time to live, example 4. Then you have your IP options. What is IP identifier? Why, I mean, let me erase this. An IP identifier. What is the list of ICMP codes? So everything is covered in your layer 3. So mostly we will be focusing on when we do a troubleshooting is we will do with ICMP codes, your TTL, IP options, identifiers, all these details will be covered there. So I'll show you there. So in layer 4, so I'll write here, I mean your layer 4, because this is all encrypted. On your layer 4, what you will see? This is called 4-tuple connection. That is your source IP, source port, destination IP, destination port. Right? So these are all the key informations. So when you go, when you dive deep into the layer 4, there comes your TCP options, retransmissions, window scaling, explicit congestion notification. So this all comes under your layer 4. So going back to the Wireshark again. If I open my layer 2, as I said, mostly you would see your destination MAC, your source MAC address. When you open your layer 3, if I am using any quality of services, you will mark your packet with DSCP. Explicit congestion notification. This ECN is different from layer 4 ECN. Layer 4 ECN is different from layer 3 ECN. So don't confuse that with the ECNs. So we are talking about the ECN only on the layer 4. We'll see that in the upcoming classes. So apart from that, in layer 3, what should I see? The other things I should concentrate on, I should see the TTL. And if you see, the layer 3 will also tell you what is the upper layer protocol that comes in after this. Say I am on layer 3, but it is telling that the next protocol comes in is TCP protocol. So you will see source IP, destination IP. So we're not going to bother about the checksum, all this value. The most important values are identification number here, source IP, destination IP, TTL, what protocol is used next. That's it. All these parameters we are going to concentrate in the upcoming classes. So the key things what you should be aware of is IP options, TTL, destination IP, source IP. Okay, so now it comes to layer 4. In layer 4, what are the informations we should see? If I type TCP, I'll take any packet here. I'll right click, always do that. Type TCP, when you learn TCP, click on any packet, any traffic between source and destination. Right click, conversation filter, TCP. Still, I don't see anything with SYN packet. So for that, what you should do, if you want to know the display filter quickly for SYN, go to Edit, Preferences, Column. So if you, again, I'm repeating this, you have to go to Edit, Preferences. You have your columns. So see, this is the columns I made it personally. And I'll show you how to do that. So here, if I want to add one more header, if I want to remove this from the column, I can remove this from a column, TCP segment length. HTTP time, I'm going to remove this from my column. So example, now I want to see my layer 2 header here when I'm troubleshooting something. So I have to click on this, right click, apply as a column. So your Ethernet header comes in here. So you are going to do a troubleshooting something related to this particular destination MAC address. Apply as a column, you will see all your destination MAC addresses. So I want to also include my source MAC address. Right click, apply as a column. I can see the source. So now you see this packet sequence. I will come back to this Cincinnati back. So when we are troubleshooting, I'm telling. So you're troubleshooting a problem. So you're trying to figure out a problem with these two connections, TCP connections. First, right click, conversation filter, UDP. Go to the very top, go there. So this is a communication from source to destination. So what is the source MAC address? You can also change your columns if you want. You can swap. So this is my Intel computer. It is going to this particular destination. So see the reverse traffic, when it happens, the source becomes the TP link and here's my destination. So how its packet is actually changing it. If you look at this, this is a destination somewhere out in the internet, but always my source for me, the next stop is my router. So always you're going to see your next stop as your destination MAC forever. But if you see the source MAC address and destination MAC address, they are same. They're not going to change. We know that when the packet flows through, they keep changing it but when you take a capture on the source side, all you can see is your source MAC address and your immediate next stop MAC address. But you can see the destination IP address. What is the actual destination IP address and what is your actual source? But the because Ethernet, it will not be broadcasted like your IP packet. It is not routed. It is local. So this is the maximum information you can see. So if there is something happening when you're troubleshooting it, here instead of going to the TP link, if it is going to a firewall, Palo Alto example I'm telling, you can figure out, right? Okay, my packet in the next stop has to go here, but instead it is going there. It can be an asymmetric routing problem. The first clue you get is, okay, it is not taking the direct path. It is taking a different path towards specific destination. This is how you have to compare your troubleshooting with. So this is how you can click and apply your filters. So this is something I'm talking about. This particular scenario is only for troubleshooting your MAC related problem. So okay, so now I have a problem with my layer 3. So you suspect that there is some problem with the routing between the same source and destination. So what should I do? I have to click on this TTL. See on the layer 3, there's a list of options here. I'm going to expand this layer 3 internet protocol, expand this. I'm going to TTL, right click, apply as a column. See, if you look at all these packets are 128. So always if you want to check your TTL, if your routing is happening, always see the packet from destination to source. So what is the destination now? 170.114.1110.137. But if I look at the source, I see the TTL is not decremented. A little background about TTL. So you got 1, 2, 3. Very, very simple devices. We will have very minimum devices. This is router 1. Router 1, this is router 2, and this is your router 3. So what happens here? First packet with it will send with TTL 1. You know, this is how the TTL works. So the next immediate device, it will decrement the TTL equal to 1 minus 1, that becomes 0. It will send TTL time to leave exceeded message back to the source. So now the TTL becomes 0. Okay, the source will get to know, okay, with TTL 1 I can't reach. So the maximum is 128. But in the internet, I think the maximum hops is, I think, more than 30 hops you can't reach a destination. Your packet is going to die. That becomes a big latency. But by protocol design, the TTL value is 128. Then for operating system, it differs. For this computer, it is 128. For some devices in Cisco, I think it is 255. And we know that what is the difference between this TCP based, sorry, UDP based and ICMP based TTL. There's two difference here. So here, if I see the TTL, it is using UDP. You can see this here. And what you see is source port and destination port. That's fine. I mean, we are not going to that now. We have a separate lab for it. So TTL becomes a 0 now. It sends a time to leave exceed message. So what happens here? Okay, there's router things now. With TTL 1, I can't reach the destination. The destination is far. So now it's going to send TTL 2. So what happens here? Comes here, the TTL becomes TTL 2 minus 1, it becomes 1. Then again, the packet will go here, it becomes TTL 1 minus 1 equal to 0. So now we come to know that there are 3 hops from my source, from my PC I'm telling. 1, 2, 3 hops. An example. So here with the TTL, how I can calculate the TTL, what it is calculated on the destination is based on TTL 64. So these are all the 3 predominant values we have for TTL. 64, 128 and 255. And if you subtract your value from 64 to 55, so what is the number of hops you got? You take 64 minus 55. So 14 minus 15. 5, 5, 10. So 9 hops, right? 9 here is 5 minus 3, 2. What is that? I am doing something wrong. 1 second. I don't want to do this. My max is bad. 64 minus 55. 9 hops. So we got 9 hops away. So from my destination, from source to destination, there are 9 hops. So it proves that I have to go through 9 layer 3 devices to reach my destination. So that's something you should see in your layer 3. If there is no routing, if just by looking into this, some people they get confused, right? Until this point, if they see, okay, I think there's some problem with the routing. If you scroll across consistently, you can see 55. So how do you troubleshoot in your real life problem? So if this is the expected output, this is the expected hops, number of hops. What if it is changing? If you have an asymmetric routing here, you should see a different value. Example, even if you see it becomes 54 hops, sorry, your TTL becomes 54, then it becomes 10 hops. So if your TTL is keep changing, so based on that, you will get to know, okay, there is some problem with the routing. It's not with the layer 4 problem. So this is how your understanding, you should do you should compare your understanding with your troubleshooting. So based on your scenario, based on your troubleshooting, you should keep changing your values. So this what do you say? This template is something you can be keep changing it. It is dynamic. You just stick to this. Based on your troubleshooting, what you're facing a problem with, you keep modifying your you keep altering your adjustments with the tape. What do you say? The template what you have here. Create your own template and do this. So in the upcoming classes, we will see what is this quick filters here. If it is something with the HTTP response problem, or if it is a HTTP redirection issue, if it is an HTTP error, we'll see that in the upcoming classes. This is day 1, right? So this is how the TTL works in the layer 3. So in every layer, it's been keep encapsulated, and we know that the destination will be keep doing this decapsulation. So now we will see the difference between hub, switch, router, and firewall very, very quickly. What is the difference with that? So we are not going to too deep about the theory. So switching happens. This is a switch, and this is a firewall. This is your PC. This is your router. We are not bothered about hub. Hub is no more used. So all you see is maximum what you will see in the layer 2. I missed one more thing. We will also see your VLAN taggings in your layer 2. Can somebody tell me why we don't see this VLAN tagging here? It is just because we didn't tag anything, or why we can't see anything related to the layer 2? In the layer 2 information, all I can see is source MAC and destination MAC. As I said, it's a VLAN tagging happens in your layer 2, but why I don't see any layer VLAN tagging packets in my layer 2? You can, if you know the answer, you can post your answers in the chat. So this is a switch. All I know, it finds is MAC addresses, right? It has both your source MAC and destination MAC. So usually what we connect with a firewall, we connect a firewall to the switch. They don't, mostly I haven't seen people connecting it to the router. So the router would be your edge device, or sometimes your firewall can be an edge based on the scenario where you feel like connecting your internet link. So from the in the firewall, the switch, we are going to discuss what's the differences with all these three. When so firewall, it can do a routing. Switch can also do a routing. Router, the whole purpose is it does routing. So even this guy is capable of TCP, and it can do an additional layer 7 inspection. Whereas this guy, he can do a layer 3, layer 4, layer 7, I mean, not deep level, right? So mostly it is used for layer 3, layer 4. So this guy works on layer 4, layer 7. I don't know. I mean, switching also some people they do, but I don't know much about that firewall. But mostly I have seen it is predominantly used for layer 7 inspection, and all your layer 4 ports are blocked, allowed, denied, and application level traffic is allowed there. So router, its whole purpose is running the big protocols in the edge, something running BGP, your OSPF. And this guy here, he can also be a layer 3 switch. He can do a routing. But in the Wireshark, when you do a capture, what should you focus on? So when you do a capture on the switch, only there you will see your VLAN tagging. So when you're troubleshooting a problem, example, you tag this on VLAN 700 example, I'm telling you. Let me take a different color. So here you tag something with VLAN 700. So what this layer 2 helps here, you compare here. Okay, instead of this, you're doing some kind of migration, and you got some additional firewall here. Your ASA firewalls is connected back to the switch. Example, this is also in VLAN 700. An example I'm telling. So both on VLAN 700 there is a duplicate, but how do you find that my packet, my next stop is, instead of going to this firewall, it is going to the ASA. Instead of this, if it is coming back to the ASA, with the help of the layer 2 headers, how it's going to tell me, instead of the destination is the TP link here, it's going to tell me, okay, it is not going to the TP link, instead it is going for Palo Alto. There's something wrong. So it's not happening. So right away when you take a capture between the source and destination, do an ICMP ping to it, and you can see, right? Even with trace route, you can find that. So this is the significance of MAC addresses. So how the MAC addresses plays a vital role there. So coming back to this, so when you do a capture here, everything when you do a capture, it is called as a TCP dump. That is nothing but if you take the whole traffic TCP dump. So even within the tool, there are options where you can select your source IP and destination IP, or else you can take the whole TCP dump. That something looks like this. But based on your problem, you have to go layer by layer. Okay, if I want to see the VLAN related information, so I am not looking at other layers. I'm going to click on a particular packet and a particular traffic. Then I have to look into my layer 2. And do I see my VLAN tagging here? And what is my destination MAC address? Is it Palo Alto or a TP link? That's it, done. So if, okay, example, if you do a routing and if your routing is not happening, then you take your TCP dump, right? Do an ICMP filter and check for your TTL. As I said, you have to go to your layer 3 and see your TTL. Okay, my firewall is 5 hops away. Example, I'm telling you, my firewall is 4 hops away or one. I think mostly it would be just 1 hop away for your firewall. So mostly I would say practically using your destination MAC addresses, you can figure out most of your problems there. Whether my traffic is, my next stop is that, is it my routing is happening, is it going there or not? It's in my proper VLANs are tagged to it. So what if I, instead of seeing a VLAN 700, if I see something VLAN 600? It's a problem, right? So it's going to a different port. The port configuration can be a problem. So some people, they may have a switch or router in the middle and it can be 2 hops away. So do I see a TTL of 2 when I do a trace route or ping? So I can go and check that. So now, okay, so there are a list of questions. So let me give an unmute permission so that you guys can ask questions. Any questions so far, what we discussed?
Sir, regarding the TTL, it's bit, can you give more, sir?
No,
Like,
okay, sure, yeah.
we-
I mean, here, we are just going through how Wireshark is used, how what is the differences. For TTL, there is a separate class here for TTL options. Yeah.
So,
Any,
Praveen,
yeah.
do we need to set up any lab on our side in the home? For
Yeah,
this,
yeah. I mean, yeah. I will explain about that. Yes, lab,
okay.
yeah, lab thing. I'll explain. Yeah, how do
Okay.
you want to build, and what are the options we have? I'll tell you. Yeah.
Sometimes we have been asked this question during troubleshooting that where exactly on the network you are doing this capture or how far you are from the source or from the destination. Because we are using span ports and we're using like extra hop tool to get the capture. So based on this TTL, we can tell how far we are from the source or from the destination. But if we have a proxy device in between, will it also change the TTL value?
If it is a layer 3 device, TTL can never be changed. It is just showing you how many hops you are from your destination, how many hops
But,
you are away from your destination.
but if we're using a full proxy, isn't it going to create another separate session
No,
from
no.
the proxy to
See,
the destination?
uh,
Will not change the TTL?
no. I'll tell you. See, uh, let me go to the whiteboard. Actually, a good question. See, if you see a proxy device, whatever in the middle, right? So if it is changing the session, if there is a proxy in the middle, forward proxy, something, it's in the middle example here. This is your source and destination. This is your proxy. So only your TCP connection is it happens from your source to your proxy, from one more TCP connection from your proxy to your destination, right? So only the TCP is creating one more new TCP session with your from your proxy to your backend server. But here in the routing, it is per hop, end to end. Nothing going to change. So if your proxy is again a layer 3 device, if it is doing the routing for you, nobody can change anything with the TTL. If you block something, you'll get a request timed out. If they block TTL, there you may you can't get your TTL messages back, because I should apparently get a TTL time to leave exceed message back to my source. Only then I can calculate my TTL. There'll be some trace routes. If you do, there will be a request timed out. There you may not see the exact TTL.
Yes, see,
So
if any proxy is there and if any firewalls are there, so if any host to initiate a trace route, to then proxy hop count or firewall hop count between the in the TTL value.
Yeah, definitely it will cover. Every hop will be covered. That's what I'm telling. See, even if, but apparently I should get the TTL exceed message to get the perfect TTL. If there is blocking something in the middle, I couldn't get the TTL exceed message if I'm not receiving the TTL exceed message back from the source. So at some situations I couldn't figure out the exact TTL to the destination. 1 or 2 hops will be different.
can you go back to the drawing that you made for the proxy?
Okay.
So let's say between the proxy and my end destination, we have 2 or 3 hops in between. Well, let's say it goes through three routers. I'm doing a capture on a third router between the proxy and the destination. The
Okay.
TTL that I will see, will that be like just 2 hops that is from the proxy? Because this connection is actually generated from an end host, right? But the capture that I'm doing is between the proxy and a third, let's say, router. As I said, there are 3 routers between the proxy and the end destination. So what's the TTL I will see? Will it the TTL that would be coming from the proxy, or will that be the coming from the actual source? You get my question?
No, TTL is actually from the source. Always the source, if
But
you are
the
doing a trace route.
proxy is generating a new connection, right? A new TCP session.
That's
It's
what
a
you're
full proxy.
confused. No, that's what you're confused. I'm telling. TCP is the only connection it is going to establish. I'm telling. Routing is happening from your source to destination, right?
Right. So
Yeah.
it's happening from source to destination.
Yeah. So there is no changes with the TTL if there is a proxy in the middle. Only in your TCP connection, you will have your one more new TCP connection between your proxy and that is a layer 4. In layer 3, nothing going to change. It's purely based on your source. Purely based on your source.
Okay.
Yeah. That's not going to change. The proxy will never change or interrupt anything. So what proxy is doing here in this scenario, it is just a proxy. It is a layer 3 device. For the TTL message what's coming from the source, it's going to send a message back. If you block it, it won't get any messages back. So it thinks, okay, I didn't get any messages. Maybe there is a device. Then again, it will send one more TTL, add one more TTL value and send to the next hop. So proxy is not changing anything in the middle. Or this scenario will never change if there is a proxy or any device firewall. It can be a firewall proxy, any routable device. No issues. Any questions?
Any RFC regarding these TCP details?
I have a document I will share for
Yes,
TTL.
please.
Yeah. I have this document for
regarding
TTL.
same TTL values related these points.
I mean, I have my document. Yeah, I will share the document related to TTL. Yeah,
Yes, thank you, Praveen.
yeah, no problem.
Praveen,
Yeah.
so you are going to share it just now
No,
on
no,
the
I mean
chat,
after
or
after the session, I would say every 15 days or 10 days once I'll be if I keep updating this documents, I will share. I will share this document by today or tomorrow. And then if there is any changes or additionally added, only if there is an update, I will send the documents, a new document. I'll roll out the new document to everyone.
okay?
Well,
Any other information that this TTL can provide us apart from that? If you are seeing a changing TTL, okay, we can say that there might be an asymmetrical routing happening somewhere, right?
Yeah. I
any
mean, that's a comparison I said. I mean, we have a separate lab for it. How if there is
okay.
an asymmetric routing, how the TTL value changes.
No, I was asking, is there any other information that we can see with the changing TTL or with this TTL? Any other information that we can get by looking at this TTL value
You
apart
can see
from?
TTL and TTL time to leave exceed messages or 2 messages you get from TTL. I mean, in the troubleshooting, you're asking about the troubleshooting,
Yes,
what you get.
yes, with troubleshooting, yeah.
Yeah, that's what I'm telling you. See, if you compare this example, if you take a capture, if you're doing some kind of troubleshooting, there is some problem. You suspect there is a problem with your routing. Go ahead and apply as a filter here. Scroll through and see if there is any disconnection or latency is happening, and if you see differences in the TTL. So all the way, if you scroll up in the whole conversation, the TTL is not more than 55. This is consistent across, yeah, between source and destination. So this proves that okay, there is no problem with the routing.
What is the value for behind the 55, 8801 and it's a
No, that's what I'm telling you. You ignore this part. This part is just an information source port and destination port. We are focusing only on this TTL here, this column.
okay.
Yeah. This information is source port and destination port.
Okay.
Here, if you see, sort out this value, just I clicked on top of here. So it is consistent across, it is 55. So what if we do a migration? Sometimes we forget to shut down a port. We forget, you may still have a routing for the same destination. It may, right? Have a routing for the same destination twice. You have your route entry. What if it is crossing a device, it is going, but it is not coming back in the same way? Then the TTL value should be different, right? We are not going to the TTL lab again, I'm telling you. This is just something how you can use your TTL in Wireshark here when you're troubleshooting. So here we are in the very basic phase of how do you make use of these values. That's it.
Praveen, it's mean 128 and the 64, it's normal. Is it right?
No, that is the maximum hops, I'm telling you.
Okay.
See,
So we are
128.
considering it's a normal TTL value for 60, 64 and 128 and
Yeah,
220.
9 hops, right? I mean 64 minus 55.
Hmm.
By looking into the values, you should know what is the TTL. How do we get the value 55? 64 minus
Oh,
55,
64
right?
minus 55, 9 hopes.
Yeah.
Suppose we can see for only 64, the constantly for all the caps. So what we consider on that?
Here there is no routing issue.
Okay,
There is no asymmetric routing.
got it. So it's normal.
It's normal.
Yeah,
It's
okay.
going. It's the two-way communication is happening properly.
Got it.
In enterprise it works, right? Because see, in actually internet there are different paths to the same destination because they have a lot of resiliency devices in the middle. But sometimes you may see a different value here. But in your enterprise, it remains constant, right? Because you design something from your data center to data center, it should take the same path, right? It should not take a different path. In that case, it helps.
Understand.
Yeah.
Maximum value is 64.
See, maximum value is 64. If you see the maximum is 30 hops. I mean, I'd never seen 19, 20 hops maximum. I never seen anything beyond 20, 25 hops or 30 hops. I never seen that.
Yeah, it's the best route.
So this is showing something 11 hops,
Correct.
right?
Yeah.
So
So like
the
that, yeah.
yeah.
Here, what I'm telling is directly it's showing 11 hops. In Wireshark, it is showing for one packet, right? So for the whole communication, it's along with the UDP, you see. And if you suspect your problem happening with the layer 4 or layer 7, there is slowness, or sometimes it disconnects. Your connection is not stable. It's keep flapping. So when the particular situation happens, you should be in a position to compare your TTLs like this. And as I said, always look for from your source perspective. I'm telling. See, here it is changed destination to source, but actually, what is the source here? My computer, 192.168.0.9 to this destination. So you should always compare your trace route from destination to source from your computer. That will give you an exact TTL value.
One more information that I can tell for sure with the TTL value of 55 is that the destination is a Linux machine, right?
I mean, it takes 9 hops to reach the destination. That's the meaning of this TTL. And
Yeah,
as I
I was
said,
saying, sorry, I said the other information that we can say that the destination is a Linux machine, right? Because Windows has 128 and Linux has a
yeah,
TTL, right?
good point. Yeah, correct. Absolutely. Yeah, you're right. I think it is now in Windows, in Windows it is a
128,
TTL of 128, yeah. Yeah.
How did you
Of
conclude that? Like, how did you conclude it's a Linux machine?
Windows using 128. When the destination is replying back, it is sending a TTL of with values of 55.
Okay.
So there are only 3 values, okay? So there are only
Okay.
3 values out there. 64, 128, 255. This is mostly Linux based operating system. They use as a TTL of from 64 maximum.
Okay.
Then this is Windows, I think. Windows, and this is Cisco. That's something I'm aware of. I don't know, maybe in Juniper, those devices, you may see TTL 64. I think it is running on top of Linux, but since Cisco is again running on top of Linux, but it has 255. It's mostly the how they design the operating system. It is decided by
Okay.
the application owners.
So you subtract 55 from 64 and you identify that it's a 9 hops away.
Yeah, correct.
Okay. Okay.
So whatever the value you get, you subtract from your maximum value. So here for 55, so why I know it is 64, I should subtract because 55 falls under 64. So 128, obviously it falls under this Windows 128. So in 128, you tell me how do you get 9 hops? So what is the TTL value in Windows then? Can you calculate?
I have one more question here. But where did I see the 64? That's what I'm looking for. Did I down?
No, this is the maximum value, I think.
Okay. No, but can't 55 come under 128? Or you have to, the value increases? That's my question is.
What's the question?
No. Okay, the value here is 55.
Okay.
Right? Okay. So that can be under 64 also 128. That's my question. Like, how did you know that it's a Linux machine?
So see, it never crosses 64.
Yes. Okay.
And it is not falling this under this range, right? So it has to if you compare the value 55 with all the 3 values, where it fits logically, it definitely fits under this value, right?
64.
Not
Yes.
this.
Yes.
So that's when we come to know, okay, it's a
So
Linux.
when you do it on a Windows machine, it might be above like 64. Is that like that?
So if it is exceeding 64, your packets will not be routed. It's dead somewhere.
Yes. Yeah.
It's going inside your black hole. I mean, it's not going to reach your destination because it's
Mm-hmm.
going beyond.
Got it. Okay.
So maximum, if you see here, the very maximum is 30 hops
30 hops.
as per the design. I mean, I haven't seen maximum 15, 16, 18, 20, but I haven't seen 32, 33 hops like that.
Okay.
So these values are based on the operating system.
Okay.
Yeah. So without
it-
this TTL,
Okay.
checking for your TCP SYN is not the right way of troubleshooting.
Mhm.
This is a primary you have to look before
Okay.
you troubleshoot a problem. It depends on a problem, I'm telling.
Do
If you're
you have similar lab coming in? I think advanced.
Yeah, this is very basic, right? Today,
Basic.
what we
That's what.
did is just we should know. I mean, you should know in Wireshark where to say TTL. And if you
Okay.
know where is TTL, people are, it's a lot of information here piled up. So I have to pick what I want for a
Okay.
particular problem. So how to make this as a column and to see.
Okay.
Maybe you didn't use this
Yeah.
before, right?
Yes. That's
Yeah.
what I'm coming to that. I'm too basic. I mean, I just run it and I never knew how to use it. That's why I'm asking this basic question.
No
Sorry for
problem.
that, guys.
No. See, here everybody is here to learn. There is nothing wrong in asking questions.
Okay.
You're always
I was
welcome to.
thinking like did I miss something in the during the session? That's what I was like asking. Like where others are able to find it out. That's why. Okay, fine. Getting closer now. Okay, fine.
Okay,
Okay.
cool. Any other questions?
Maybe a
Mm.
basic question.
Mm-hmm.
So if we have a network loop, suppose router 1, 2, 3, 4,
Mm-hmm.
and somewhere the packet is roaming between them, there is no specific route available.
Mm-hmm.
So where the TTL will decremented or not? I
So example, you have
yeah,
you're telling about the routing loop.
correct. We have R1, R2, R3, and when R1 sends R2, again R2 sees, so the best route is again back to R1. And yeah, it's just ping pong here, R1 to R2, then R2 to R1.
Okay.
So there it will the TTL will be counted with yeah, that I never.
You have to compare with your working scenario. Example, instead of trying to this, I mean, you're trying to figure out a problem for a specific destination. Try with a different destination. Compare the TTL values against your value. Say, for example, both are going through the same router, but both are a different destination. But you have a problem. You might have a problem with a specific subnet, right? Or maybe the whole subnet.
Yeah,
What is
specific subnet, correct.
a
Yeah.
specific subnet? You do a troubleshooting for a specific subnet, capture your traffic, see the TTL, do a trace route for a different destination where everything works properly. Your known working scenario and a problematic scenario. Compare both, check the TTL. If you see the changes in TTL, then you will get to know, right? I mean, who's doing
Yeah.
it what. By hop, how you can figure out then, as I said, you have to see, is it my next hop is going to the correct destination MAC address. If it is a Palo Alto, always it should show me Palo Alto. If it is showing a Cisco device, always Cisco. But on top of that, even the MAC address is unique, isn't it? So if it is going, my next hop is going to a different Cisco box, then it is a problem, right?
Yeah. It should be always between same two max. The packet should.
For your
roam.
source and destination, what is the next hop destination MAC address you see on your Wireshark for both scenarios? So is it going to the same device or a different device, same VLAN or a different VLAN? All this information you will get there.
That I can see here in the first Ethernet packet, then the destination MAC.
Yeah, here.
Okay, in the IP,
Here, the source
the
MAC,
second one. Okay.
destination MAC. So it's going back to the Intel. Here, always constant.
Okay.
It is between Intel and my TP link because that's a two routed ports, right? From my computer to that.
Okay.
So always goes to that gateway. See here, my gateway is TP-Link.
Okay. Yeah.
And
Let's
also,
see.
you in the enterprise, in addition, what you can see is there will be a scenario there we will see when you tag your packet in the layer 3, you can't see because it is not doing any kind of tagging, right? My PC or my router.
Mm-hmm.
Here is just a flat VLAN. But when you take a capture in your switch, which is in the middle, then you will get to know, right? I mean, what is my next stop from the switch, from the layer 2
Yeah.
perspective, VLANs. Is it my VLANs are matching or not for both routes?
Yeah. I'll see.
And also you have that, see, if there is some duplicate IP address, if you have configured on one on the ASA, one on a Palo Alto or FortiGate, whatever it is, you can still see here when you do a trace route. It will try to go out of both ports, right? Maybe first time it may go out of this, but it's coming back through the Palo Alto and Cisco instead of ASA to Cisco. Got it? What I'm
Yeah.
saying?
Yeah.
Yeah, you have to compare both sides. And always it is better to take capture on source and destination, both sides.
So,
Yeah.
Praveen, one question. Is
Yeah.
that possible? Like if in the 64 range, we can get the inconsistency in the TTL, like right now it's showing that all 50, 55, that right? 55.
Mm-hmm.
But is that possible? We can get the inconsistency, like sometime 55, sometime 45. Like, is that possible?
Not very, you can't expect every time like 45, 55 changing like that. Maybe one or two hops might be changing at times.
So what happened in that scenario, like when there is a inconsistency in the TTL?
Then, as I said, you have to compare with your MAC addresses and VLANs if you're tagging.
Mhm.
If it is a layer 3 port, then you don't see anything related to VLAN information. All you have to check your MAC addresses. Is it both MAC addresses are same for both trace routes?
Okay.
If there is any asymmetric routing or routing issue, what will be the TTL? Praveen?
No, it depends on the design. I mean, if it is an asymmetric routing, your expected TTL is 55, and if it is going 56, 57, then it is a problem. Then you have to compare your MAC addresses. See, just checking from source, you can't figure out everything, right? So when you have to take a capture on your source and destination, both end. Compare. For in the both results, do you see the same layer 2 information there? Same TTL or a different TTL? Then you will figure out, right? So okay, from my destination, it is going out in a different MAC addresses. First thing you will check in your routing table, isn't it? I'll go and check, do I have a duplicate route entry for the destination, or I am doing some kind of policy based routing? Is it something I am doing with the routing here, isn't it? You heard me, Satya?
Yes. Yeah.
Yeah.
All
See,
three
we are in the very beginning. Okay, don't confuse much. I mean, with this conclusion, with this capture, why I am not getting the results? No, this is I am just showing you where to see TTL. That's it. We are not discussing too much today because it's the first day of a class. We should know what is Wireshark, what is the values, how do I apply? Because some people they might be very new, right, to Wireshark.
Yes, sir. I got that. Yeah.
Yeah. Don't worry, we have a specific lab for TTL with multiple scenarios. We'll do the simulation.
Okay.
Yeah, Nagesh.
So you might, like see in this lot of cases the issues, right? So you are explaining like the way it's like, as you know, right? So is there any way like do we get some document like example, this is the issue and this is the what filter normally, and that this is how we have to check all things what you have explained.
What are you expecting? What document?
I mean, the way you are showing, right? Example, we have to
mm,
go into the layers, right?
mm,
Layer
mm,
2, layer 3. Like,
mm,
suppose you got like any of the issues and you have seen the issues, right? Like,
mm.
for these issues, you have went to this layer 2. After in the layer 2, we seen these are the all things are good. And then go for the layer 3, right? So all the basic thing we check in case of any issues are like these are the basic thing we have to go capture the packet and check the all packet like that. You got it, right?
I got it. I'll give you a very simple example. When your max teacher is teaching something, you will go to
Yeah.
home and then you'll do
No, I
your
will do it.
max.
I
No,
will
no,
do
no,
it.
no, no. I'll ask you. You'll do your homework, or you'll expect
Yeah.
your max teacher to write step one, 1 + 1 equal to 2. Step two, 3 + 2 equal to 5. Now I got the answer. You follow that. Do you think this is going to work for all the problems?
No, I'm just saying it
No,
is
no, no.
just.
What I am trying to say is, see, here
Yeah.
Wireshark is very creative.
Mm.
Here more you have to be very logical.
Yeah,
So
correct.
I am what is that? You are
Mm.
an artist. I am writing, giving a background, strong background. I'm drawing the outline. You have to
Mm.
fill up the space. You have to
Mm.
do a lot of hard work, Nagesh.
Correct.
Say
No,
you
no.
have to go home,
Mm.
take multiple capture, compare the
Mm.
TTL, watch my recording. I'll give a document that helps. But
Mm.
I don't know. Some people, you guys have a mindset that okay, if I refer this RFC, how many people are well versed and you know everything about RFC? Do we really apply everything from RFC? I'm not telling
Mm.
reading RFC is wrong, but don't have the feeling of okay, I have RFC, I learned everything. Even
No,
I had this
nothing.
satisfaction long back, 6, 7 years back. Okay, I will collect all the documents, I'll collect all the recordings. Oh my god, I am good. I'll be troubleshooting. I mean, I'll be the master of troubleshooting in my company. It's not
I
going to
have
work like that.
no, yes, Praveen. I have some doubts with that. I think just clarify the via RFC because I'm joined something
No, 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 no. I
little
am
bit
not
late.
pinpoint. No, no, I got it. I am not pinpointing an example. I am telling. Here is more. You have to do an hands-on. That's my whole point.
No,
So
that
only
you
with
see.
this, yeah,
No, no.
only with this, you can't do that. I mean, see, just with this explanation is very simple. This is a place I am showing you. Okay, this is TTL. Then you have to go back research. Okay, what is it really? Google it, Chat GPT. Do what is the different kind of TTLs what we have, how TTL works. Then you come back. You learn. You will be the master of it. So that's why we are here. I am not telling I am not going to teach you. I will definitely teach you. But don't have that expectation that with just documents I can be the master. That's never going to happen, man. Believe
No,
me.
no. So
You have to
no,
do a
no.
lot of hands-on. You have to
So
practice
the
a lot.
basic is we have enrolled this course. That means obviously we are getting this all things. What you are saying, right?
Yeah, yeah,
The
yeah, yeah.
only the only thing was if sometime will we know there is second we'll be having some like in kind of a thing like we'll be occupied with all such things, right? We'll be
Hmm.
saying yeah like as like the everyone will do their cheat sheet or something. They put their notes right after doing these things.
I will give you, see,
Yeah,
there is a document where I will give you the list of filters what you have for it.
yeah.
But
That's what I.
the what I am telling is, without
Mm,
knowing the foundation, how do you know
mm.
that which particular filter I should use for it?
Yeah, correct. That is that. Yeah,
Correct?
yeah.
Ethernet dot destination, where I
Mm.
should use Ethernet dot destination, which particular scenario I should use, right?
Yeah, that is
Asymmetric routing, and I want to compare the TTL. You have to simulate your asymmetric routing first, then you should do a proper routing and you have to compare. This level of minimum hard work is required, I am telling. I'm not telling you are
no,
not
no.
doing it. For everyone, I am telling this is a very minimum hard work that is needed.
Yeah,
So
yeah. To
to
get.
get that understanding, right? When you learn about any protocol or anything, you just compare yourself with 5 years back and how you are now. Definitely, you will get deeper and deeper, and your understanding gets better. So for Wireshark, it is all new for everyone. So this all is scattered here and there. So, but for a particular troubleshooting, how I can make my own template
Correct.
to figure out a problem.
Yeah.
Then go by layer. And
Sure.
try to learn what is very essential. I'm telling you're telling, right? So even I felt that, so instead of just learning about everything, what is detail, what is ARP, it's not going to help. So what is exactly required for us, for ARP related or maybe a TTL related, what exactly needed? Just focus, limit your time, be smart and learn. That's my piece of advice if I want to tell you. if you want to learn about a specific topic.
Yeah.
Okay, yeah, I will definitely give a document. Don't worry. I mean, I have those documents for TTLs. I will definitely send those TTL documents. I'll try to. This is the day one, right? So I think still I'm sharing my screen.
Yes.
I will open my PPT. I think I should have my TTL somewhere here. See, if you want to detect a broadcast from, this is a filter you have to use. If you have, it's gone, VLAN related information, you have a filter. I'll go to the top.
All these Cisco related document.
Yeah. No, this is not sales. All I've collected from internet, multiple sources.
Okay.
There are an option to search.
Praveen, how much time you took to be, well versed with this Wireshark? I've been trying since last couple of years.
What is the question? What is be
I
consistent
am asking.
for us? Do really? I'm telling. Be consistent for at least 2 hours in a day, or maybe 4 hours in a week is fine. Take multiple captures, whatever we are learning, and also you compare. Understand first what is layer 2, layer 3, how this packet is keep changing it, everything. But you have to be very dedicated. You keep doing for 7, 8 months, 1 year. I think you will be well versed. It's not happening in overnight, man. For
Yeah,
sure.
as I said, I've been trying this for the last couple of years, but still, yeah, consistency is one of the things.
And do
So
one more thing. Whenever something you are going to your work every day, you are starting your work, right? You just keep one mindset that okay, I am doing something. Spend some time like half an hour, 1 hour in a day, just for a normal communication. Figure out. Don't try to find a problem. Just learn. I mean, okay, what is it? Routing is happening. Okay, what is TTL? Okay, what is IP option? He said, okay. Do you see something DHCP option? Where to see? Do I see VLAN tagging? Can I see any resets, any retransmissions? What is that? I mean, when we are learning parallelly, I am telling, try to do that. It becomes your habit because that's what I do. Even now, sometimes, even though there is no problem with something, I'll try to do a capture. Okay, in this scenario, how this SSL is different from here. Something like that. It's an everyday learning you should have. Don't just stop with what we are discussing. You explore more.
okay,
Yeah. And don't have a feeling that I will not teach anything. I will teach everything for sure. But I am telling beyond that you have to push your limit, I am telling. Yeah. Any other questions, guys? Related to today's topic. If you want to recap or if you guys have a understanding problem with understanding the TTL. TTL or maybe the Wireshark options, whatever.
Yes, better. I think I have one question. Max Wireshark maximum point cover in the TTL value, main point, I think. With the TTL value to define everything. I think first we check any troubleshooting via Wireshark to first find out the TTL value, then after start the source, destination and other part.
Uh, it depends on your scenario. Example, if you have only problem with your resets or TCP connections, then you don't want to bother your TTL. If you really feel like you don't have any problem with your layer 3 routing. If you can ping across and but you can't establish a connection on a specific port, so you don't need to check TTL there.
Okay. Thank you.
So it depends on you have to be a little logical with that when you think where TTL is needed. But in the beginning, always check, if you ask me.
Yeah.
Even though if your routing is proper, still there is no harm in checking your TTL. You'll understand. We will have a separate lab for TTL. We'll do the simulation and we'll see the difference.
Yes, thank you.
Hop by hop. Yeah. Okay.
Praveen, it's Amol here. So I have query related to the destination MAC address. Okay,
Yeah,
when
yeah.
I'm ping from a host A to B,
Okay.
okay, in between we have the multiple layer 3 devices.
Mm.
Then what would be the next that MAC address? Do we get the original MAC address or next layer 3 device MAC address as
No,
an destination?
next layer 3 device MAC address you will get.
Okay.
Only that I can see from the source.
Okay.
I can't see beyond that from Wireshark. Yeah.
Okay. Yeah. Thank you.
But I would suggest do a TCP dump on source and destination, both sides.
Oh. Okay, sure.
Yeah.
Thank you.
Yeah, no problem. No more. Yeah.
What? Yeah, can we also learn about how to take Wireshark capture? Yeah, maybe the capturing a file on Linux server or something, or only analyzing of the Wireshark capture.
Linux server.
Yeah,
You mean
usually we get issues with
maybe
the Linux devices.
I will give the commands. I'll give the commands,
Yeah,
and
okay.
maybe if we are doing other scenarios, we will try. We'll take a TCP dump in Linux box. We'll do that.
Okay.
In the class, in the training, we'll do that. Yeah, I'll show you. And also, I'll give a document for everything what we are doing.
Okay.
Any other questions, guys?
Yeah, I just want to ask a thing. Is there any way we can decrypt the VPN traffic on the Shark?
VPN traffic.
Yep. Any VPN?
SSL we can decrypt. VPN is something I'll let you know about decrypting VPN. But we will go to all the packets in VPN. I mean, we can't see the payload what is inside the VPN. Other than that, all your VPN messages and packets, we will do. We have a separate class, a very detailed lab for it.
Okay.
The only thing is we can't see the payload inside your ESP.
So if the ESP is going on the Shark, so how come we can decrypt or see about the traffic or get any information about the traffic?
We will see all the other messages apart from the payload, right? Before the encryption, the main thing is we'll see the proposals, the algorithm used for key encryption, hash, and all the 6 main mode messages. You will see, and then on top of that, once it is encrypted, we can't see anything there.
I think Praveen, like if you do have a key, we can, right? The pre-shared keys that has been used for the encryptions.
Yeah, I think we can see the pre-shared.
Because when I was in attack in Palo, like for deep troubleshooting, like we tend to take the keys and
Yeah, that's what
we'll
I said.
take.
I mean, Javed, I mean, I tried long back in decrypting the VPN traffic. It worked 1 or twice, I think. How do you do that? I mean, you take a pre-shared key and decrypt it?
Yes. There is a log collector tool, but it is not available outside or globally. Like it is for the tag purpose. It's organizational limited. So from there, there is a log analyzer tool. In that, like whatever the configurations that we do with the pre-shared keys that we configure for the VPNs, we will be able to tend to export that keys. There is a process like 3 to 4 steps. So after taking that key, like in the Wireshark, like there is a place, I forgot it. So we have to go
Here,
there
you
and
mean
in the
what is
Wireshark.
that? I will share. I think you should be using here, I think. Mm,
Protocols.
TLS here, preset key.
Yeah, there.
Okay. For SSL, yeah, we have a decryption class for SSL, but I haven't tried for VPN.
IPsec. Even IPsec there is, like I'll just try to recap and I'll tell you in next class.
And is it for the pre-shared key? If I remember, this is the pre-master secret has all the key material to decrypt the traffic, but with
Yeah,
just
pre-master key I'm referring to. Yeah,
oh,
sorry,
you're telling
pre-master
about
key.
yeah,
Pre-master key only.
that is possible. I don't think because pre-shared key is only for authentication, right?
Authentication, yeah.
Yeah.
Yeah, I believe so. Like pre-share key is also all needed as a subject of the SSL, right? But in IPsec, if we will just see, IPsec is something else. So I don't think so we can decrypt that traffic onto the Wireshark or any other tool, right?
I think let's see. I mean, what is the way of collecting this key material pre-master? Because there we use in SSL there is an option like that. The browser creates a pre-master secret, but in the VPN process, it's key encryption hash. Then your session key exchange happens between source and destination, and after that everything will be encrypted back. And I don't know how to capture those key material, something like a pre-master. I'll research on that and I'll let you know. Yeah. Anything else? Any other questions?
Praveen, in the lab, you'll be creating a lab, capturing the lab on the like routers, span ports, firewalls, load balancers, everything, right?
Yeah.
Okay, so it'll be a full topology kind of an lab setup.
Yeah.
Okay.
Tomorrow I will show you what is the lab requirements and how to build a lab.
Gotcha. Okay.
Yeah.
So I think you need a RAM laptop with a high RAM and stuff like that.
No, I think 16 GB is fine. I think 16 GB is fine. So
But if
to
you don't
run,
have 16 GB, what's the other option we have?
I think there is an option for rent. If you are interested in rented labs, I think it costs you 2,000 rupees per month.
And that's on cloud, is it?
Yeah, it's on cloud. Yeah.
Achha, okay. So I have to pay for that 2K.
Yeah. If you want to separately go for it.
Okay. Okay. And but you will be suggesting how to set up the topology in the cloud, yeah?
Cloud, no. I mean, in the PC, yeah. In the PC, I will show you how to do that.
No, but can I replicate the same thing on the cloud if I don't have that capacity of RAM in my laptop?
That's something I'll talk to my team internally about deploying cloud. I have seen Hemu shown some videos to deploy in cloud.
Okay.
I'll ask Hemu and then
Okay, got it. But ideally, you'll be doing a full topologies on the PC itself, like
PC. Yeah.
Okay.
Correct. Yeah.
Okay.
And the RDP. Yeah.
Okay.
So you guys are scared that only with Wireshark we'll be continuing the training.
No, but the thing is that when
got it, yeah.
capturing, when you say like you need
to
source and destination, right? So we need to take the full cycle of the logs to see what's happening where, yeah.
Correct.
Okay.
I mean, today, tomorrow I will show you the lab. Actually, today is just to give you an introduction about Wireshark. What are all the options we have there? That's it.
Okay, got it. Okay, man. Thanks.
Yeah. Thank you. If I have a quick, let me share my screen how the lab looks like.
Yes, please.
Okay, sir, very worried about labs.
So Praveen, I'll be also looking for that right, a rental one. Okay.
Oh, is it? Okay.
Yeah.
second, I think.
If I configure ENG in our laptop, the minimum requirement, I think 12 GB.
I think 16 would be perfect.
Okay.
I think okay, I can do only 2. Okay. If I go right click, capture, Ethernet. So it should be something like this.
Praveen,
Wow.
do we need to install VNG on our laptops?
Yeah, correct. EVNG on your laptops. Even if you have the GNS is also fine.
If you have set up, the please share. I think EVNG.
I mean, tomorrow I will explain you. I mean, even we will give the setup files for build the labs. Yeah.
Yeah.
What's this tool called, Praveen? Can you repeat the name again?
This one, PNet Lab.
PNet, yeah.
Yeah, PNet Lab, yeah.
Is it some VNG, right? What's this?
EVNG, EVNG,
Okay.
EV-NG.
Okay. EVNG.
This one.
Okay, got it.
I have it, but need to.
Okay. I think I don't know the difference, but some people they say PNet is better. You can do something with PNet that you can't do it on. Yeah, even though it is connected, I think you can connect your links. But I think in EVNG you have to stop the node, and when you want to connect the devices,
Yeah.
to do
So
cabling,
Mm-hmm.
you have to turn off. I think right in EVNG you have to turn off, and you have to connect the device. But in
Yeah.
PNet, I think even if it is turned on, you can do it.
If you remove anything in ENG, then remove shut down all lab. Then after you modify, I think.
Some advantages with PNet, I think.
Are these free? I mean, not chargeable, is it? Like to put the
I
device?
think PNet is just free. I think PNet is free. All you
Even
have to do is
EVNG.
EVNG. Yeah, both are free. Yeah.
Oh.
Images are the things that we should.
Even in professional version, you can equally connect the device when it is powered on. It is only the community edition you like.
Maximum lab.
And what about the professional? Is it is preloaded with all the images, or we have to upload the images to?
You have to.
You have to. Just the difference is number of nodes, right?
Yeah.
Okay.
Yes, and.
But for the images, we have to purchase, is it? Like.
Maybe a lot of cracked images.
Versions are
the images are all over the internet. You just need to look for the right resource. You can get them.
Like just like the trial version, cloud version images.
No. I think there is some. They do something. I mean, you will get images you can download from sources from the internet.
Most of them are chemo images. Some of them are IOLs. The chemo images, many of them are available.
But this lab doesn't give it like inbuilt. You have to download and probably do like installation upgrade kind of a thing.
It's like starting from the scratch. You have to build your own topology. So everyone have to use a different image depending on the topology. So you just need images.
But Pradeep, if you have if you feel like okay, I don't have time in doing that, I think there are rented labs now. There is everything is preloaded. They will give an access. Then you can log in and you can start using it. Pay 2,000 per month, 10 notes, I think. You get 10 notes, more than enough. Practice for 2 months completely.
Okay.
Not only for this course, maybe you can practice everything.
For everything. Yeah.
Yes,
So if we
yeah.
can share some details on that, Praveen, it will be very awesome.
Yeah, you want the detail?
Yeah, on that. Yeah, where
Yeah.
where is it available? Yeah.
Yeah, I will give you the detail. Sure.
Perfect. Yeah, perfect.
Ping me in the chat. I'll give you.
Oh, that. Yeah.
Yeah. See, if you see this is a rental lab where if I go and add a device, I have all the devices here.
This peanut is similar to EVNG?
Yeah,
Kind of
similar
similar
to EVNG. Yeah.
The images are pre-installed or is it a pre-contains? How is it, Praveen? Like again,
Rented is preloaded. All the images are preloaded images.
Okay, for PNet. Okay.
Yeah, they are giving it for PNet, this guy, and he has mostly all the images. But one thing what I had problem is when I had my SD-WAN lab, for Palo Alto switches and routers, it works perfectly. But where I had two scenarios where I tried to replicate my VXLANs and SD-WAN, but the output didn't come out. I mean, I had problem. I couldn't figure out, and then I tried with TAC, but the same configuration works there, but not here. But I'm telling only for VXLAN and SD-WAN. But apart from that, for routers and switches, normal routing, switching, and firewalls, this is good.
Sorry, can you come again? What did you say your issue with VXLAN was?
No, VXLAN was because I see my EBGP connection, then I see the advertisements and everything, but I can't ping across, and that is not properly working. So it's just like I have everything, the configuration, everything, and Cisco TAC suggested a code, and I tried the same code on the Nexus, but still the VXLAN tunnel didn't happen. I don't know. He said it's a problem with your OS. I tried with the same version what he tried with, but he did it on Cisco modeling lab. Tried right here, but didn't work. And here, SD-WAN, what the scenario, what I had a problem is my vManage never came up. I tried all the steps. I took almost like 3-4 months, but I couldn't figure out. I don't know. Maybe it can be a license issue also. But I had these two problems with this lab. So, but for Wireshark training, I never had.
That's one thing I've noticed. I've experimented with PNet Lab and then EVNG. I'm not promoting one, but what I realize is sometimes PNet Lab is buggy.
Bad, right?
It's buggy. Some of the things you try and then they don't work, but when you go to EVNG, then they work.
EVNG is better, you mean to say?
Yeah, yes.
Even I had the feeling actually. But for basic routing and firewall, I think it never had any problem with that.
Yeah.
But sometimes it happened for me, where in the EVNG and PNet also, if you have experience, I don't know. Sometimes the IPsec for me, especially when I build an IPsec, I have to remove the crypto map and I have to apply again. Only then the IPsec messages starts kicking. Sometimes it happens like that. So there is a glitches for sure, but we have to figure out and we have to be patient sometimes.
Yeah.
Because this is all cut versions, right? It's not actually the proper, what do you say, the firmware what we are downloading here. It's a cut version from different sources. It may have a bug for sure. Yeah, I mean, any other questions? I mean, this is how the lab looks like. The maximum you'll be using like this 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would say go if you want to go for the lab, have RAM capacity 16 GB RAM is sufficient, I think. Maximum you'll be using 2 firewalls, 1 router, 2 Linux boxes.
Praveen, you will be providing all this information about the lab?
Yeah. Tomorrow I'll tell you about how to build this lab, and we'll also give you the images to build the labs, the links to download and build the lab.
Okay.
By the way, how much you are paying for this virtual cloud lab? Is it really expensive or?
I'll tell you. You come. You ping me in the separate chat. I'll tell
Okay.
you.
Okay.
Yeah. This is not owned by us. This is something I bought this for training. I used to buy this labs.
Which cloud is this on, Praveen, if I may know?
I don't think this is a cloud, Pradeep. This is he's running on the VM ESXi, and he is giving an access to us.
Okay. So it's like something locally built.
Yeah, built, and he made the web version of it. He's giving the web access to it.
Okay. Got it.
And yeah, we can use it. And also he can give RDP connection also.
Okay. Got it. Oh, okay.
But I
will we-
feel the web version is better. When RDP you can use as a second option. Why? Because see, if you have some kind of commands to test, see if I want to copy paste, I can do a copy paste directly in the web version. But in RDP, every time you have to open it up, it will pain.
Yeah.
But the web version is very quick. If you want to apply something, see if you want to apply something configuration side by side, you can copy paste, right? You can copy paste side by side. You can do that.
Got it.
So this cloud lab will be having all the images, like even for the
Yeah,
Palo Alto.
most of the images I have seen here. Palo Alto. Okay. Even they have what do you say, Panorama, but I haven't tried. Ostinato. Oh my God! See, I didn't see that. This is a very good traffic generator tool. I never tried this. Ostinato.
Praveen, like, will we be able to modify the topology, or we need to work on the same topology that is already preloaded?
No. This is all. It's completely your kingdom. Whatever you want, you can do it here.
Okay, understood. Because in some areas, like according to the concepts, they'll set the topologies, and we can't modify them.
Yeah. I have seen a few institutes they do that. That's very annoying. I mean, you can't do anything apart from that, right?
Yeah.
So this is your own lab. You can do whatever you want.
And this is pay as you go, Praveen, or is this like a monthly basis, subscription based? Is it?
No, I think he's giving some discounts when you go for 6 months plan.
Okay.
Some discounts. If you pay more, you will get more benefit, I think.
Okay, like annual subscription. And stuff like that.
Yeah. He will release some price for it.
Okay. Got it. Just send me those details on the chat. I just pinged you already.
Yeah. Okay, sure. After this class, yeah, sure.
Yeah, perfect. Yeah. Thanks a lot.
Thanks. Yeah. Any other questions, guys? Any questions about the sessions and how we are going? Anything, whatever you feel, you can talk.
So this recording will be available, right, after this?
Yeah. Yes.
Praveen, sorry.
Every day, 1 second. Sorry to stop, Balchandra, right? Somebody asked a question. This recording is every day. It is recorded and uploaded in the cloud, and maybe it will give us one last time. Maybe the recording what is happening today, you should see this tomorrow morning. Sorry, tomorrow morning or maybe evening. Sometimes on Saturdays, Sundays, it will be little. You have to wait for 24 hours, I would say.
Thanks.
The maximum time, I'm telling.
No, Praveen, where do you send the recording?
No. I mean, they will give a portal access for you. You can reach out to Muskan. You know Muskan, right? You would have done your inquiry to her, Muskan. Do you have Muskan contact number, Joseph? She has. No, see,
there is one I have,
see,
but
in the chat you have something like if you want to enroll or if you have any queries, it is in the chat window. If you see, after this meeting, you can't copy this. If whatever you guys have questions related to recording and the portal access, you can reach out to this number. Yeah.
Thank you.
Got it, Joseph? Yeah,
yes.
Bala.
Yes.
Chandra. Yeah.
Thanks.
Thanks, Joseph. Yeah. Tell me, Bala Chandra.
So you have taken some topics like OSPF, BGP you are covering. So similarly, like for VXLAN and SDN, any SDN, if there is a session or something, if it's possible, if we can include, like I think VXLAN will be, if we are working on a data center and troubleshooting, it'll be helpful. So something, if it's possible, like just see how much it's feasible. Or
Yeah, I don't think we have included in this course, but I can give you documents. That's again a personal thing I'm doing.
okay, I mean,
I can give you, but
like
that is not in the topic here.
okay, in case if the tunnel is established in the VX, I mean between source and destination, we will be having some tunnels right in the VXLAN. So when we do a capture, what we will be able to see how we can in the captures, just to if possible.
Do you have any environment where you have your Nexus devices?
Yeah. I work in a data center and also in a ACI environment. So we have some environments, but